Hello everybody and welcome to example 5. We're still looking at page 18 of the workbook. And this is going to be another example of using the integral tables to help us calculate integrals. Okay, and before we dive into this example, I just want to say a couple of words about what might help you to navigate through the integral table. There are a lot of formulas on there, so I want to make you aware of the fact that they're organized by categories, and I want to share with you the 4 major categories. Not every formula on the sheet fits these 4 forms, but most of them do. Okay, so here goes. So a squared minus u squared, a squared plus u squared minus a squared, or a plus bu. Okay, and so those are 4 forms that come up a lot, and I want you to also be aware of the fact that when you see those forms, u always represents a variable and a and b are constant. That's important to remember. Okay, so an approach that I recommend when you're doing problems like this is to look at your integral and ask, which of those forms, if any, does that appear to match the best? Okay, so the square root of 4x squared minus 5. If you had to pick one of those forms, which do you think fits the best? Okay, if I had to pick one, I would probably choose this one. I'm looking under the square root and noticing that we've got something with variables in it squared first. So it's probably going to be u squared minus a squared. Okay, so if we make that observation at the start, it sort of gives us a roadmap as to how we might navigate our way through this problem. Okay, so start by asking yourself, how could we rewrite this expression so that it fits u squared minus a squared? So we're kind of trying to fill in the blanks here. So can you think of something that when we square it would give us 4x squared? Okay, well, if you think about it for a minute, you might come up with 2x. If we take 2x and square that whole thing, we're going to get 4x squared. So that's kind of the magic thing that we need in the parentheses. Now, what about the 5? Okay, what number squared would give us 5? Okay, 5 is not a perfect square, so there we have to cheat a little bit. Okay, if we put a square root of 5 in there, that squared is going to give us 5. Okay, so we've just rewritten our integral in a way that kind of makes it match this form u squared minus a squared. Okay, then the next thing you might ask yourself is, does this suggest a possible u substitution? Okay, well, let's let u be the 2x that we have in here. That's the inside of a function, so it's kind of a natural choice. And if we make that choice, then the derivative of u is going to be 2. We'll stick a dx on the end of it. And solving for the dx, we're going to get du over 2 equals dx. Okay, let's put this aside. And so if we rewrite our integral, making the substitution, we're going to get, let's see, u squared minus the square root of 5 squared, and dx is going to become du over 2. And we can take that over 2 and write it and bring it to the outside of the integral. Okay, so far here's what we've done. We've taken our integral and we've rewritten it so that it matches this form up here, u squared minus a squared. Now we are ready to go to our integral table and see if we can find a match for this formula. Okay, so let's do that. Okay, I'm going to go back to the beginning of it. And remember that the form that we chose was u squared minus a squared. So forms involving a squared plus u squared, that doesn't match. A squared minus u squared, that also doesn't match. We're looking for u squared minus a squared. Aha! And here on page 2, we have forms involving the square root of u squared minus a squared. That's what our integral looked like. And notice that the first formula on that group, 39, appears to match. Okay, square root of u squared minus a squared, that's exactly what we were integrating, where the value of a was the square root of 5. Okay, so formula 39 tells us that our antiderivative should look like this. We're just going to write down that antiderivative and write in square root of 5 everywhere that we see an a. Okay, So back to this page, I'm going to first write that down, the formula that we got. Okay, and if you're doing this on a computer, you might want to have two windows open, one where you can see the problem and one where you can see the integral table. Okay, I'm going to write down the antiderivative that formula 39 gave us. It looked like this: u over 2 square root of u squared minus a squared minus a squared, so square root of 5 squared over 2, natural log of the absolute value of u plus the square root of u squared minus a squared, okay, plus a c on the end. Okay, wow, that is a long antiderivative, but the table told us what the antiderivative is, so all that's really left for us to do is to fill in what the u was equal to. Okay, u was equal to 2x in our case, so we're going to get, let's see, 2x over 2, square root of u squared. If you square 2x, you're going to get 4x squared again. And square root of 5 squared, we might as well write that as 5 again. Okay, so let's see, square root of 5 over 2 is 5 halves ln of the absolute value of 2x. Okay, and then u squared again is 2x squared. That's 4x squared minus 5. Okay, and then plus a c. Okay, now that would be perfectly okay as a final answer, but we could do a little simplifying here. Notice that these 2's go away, for example. I'm going to cancel those and just rewrite this one more time. For x squared minus 5 halves ln absolute value of 2x plus the square root of 4x squared minus 5 plus c. Okay, if you wanted to, you could distribute the 1/2 through, okay, but we don't really have to do that. I'm just going to take this as our final answer.